All right, here we go. So today's lecture, we're going to talk about matrices, which is chapter 6.1 in the ordered number system. I'm going to scribble this off. Okay. Now, if you haven't heard of a matrix before or have never seen one before, it looks like two big brackets, usually long, and they contain a few rows of numbers. It depends on how many equations, how many equations you're going to use, and columns depending on how many variables you're going to use. Now, these columns and these rows are usually associated with a system of equations. Now, if you remember in section 5.1, where I gave you a system of equations and told you that this right here, for example, is a system of equation, and you have one specific x that makes both equations true and one specific y that makes both equations true, and I asked you to solve for this, we learned how to do that. But what if I gave you x plus y plus z equals 13, right? So if I gave you three variables, this is a different system. If I give you three variables, then in that case, you're going to need three different equations because you're going to need to solve about 3 times before you can find what each variable equals. So the number of equations you need is the number of variables you have. So since I gave you 2, you need 2 equations. Since I gave you 3, you're going to need 3 equations. I'm just writing something randomly to whatever that is, which doesn't make sense. But anyway, so this is another system of equations, and this one you have 3. What if I give you 4? What if I put another letter here, or 5, or 6, or 7? Can you imagine solving a system of equation where you have 7 variables and obviously 7 equations to do that? That's going to be a little tricky. That's why we have matrices. They make this tedious process so much easier. Now, solving it by hand is usually easier if you're doing it 2 by 2. But if you do more, a matrix is a lot easier. So the first step we need to learn is how to translate a system into a matrix. We're going to write this in this form. So the numbers you see in a matrix are the numbers of this system. You're just going to remove the variables. Each variable is going to have its own column. And each equation is going to have its own row. All right? So let me start off with example number 1 in the notes. Now we have 3x minus y, and it equals 10. And then you have 5y, and it equals 12. All right? Now I didn't give you an x. That automatically means that what? X is a 0. You have 0x plus that number. Make sense? That's why it's not there. Now, if I want to translate this to a matrix, you draw the bracket. Yes? Now, first column is going to be the x's. Each row is going to be a different equation. So this is my equation number 1, equation number 2, right? So number 1, number 2. They go in that order. Now, since this is the x column, right here, first one, you're going to have 3 in the first row and the 0 in the second one. Now, for the y column, you're going to have a -1. See that? Since it's minus y, that means it's a -1. You have a -1 in the first equation column row for the y, and a +5 for the second equation. Yeah? And last but not least, the answers. You write the 10 for the first equation and the 12 for the second equation. But you draw a line right here to separate. This tells you that these 2 numbers right here are the answers of the system. Make sense? So these are the variables, that's the answer, variables, answer. And then you close the matrix. Simple enough. Now every time you do this, you're not going to write x, y, z, blah, 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 blah. You just understand that each column is a different variable, each row is a different equation. but for the first time, or a few first times, let's say, we're going to do this. Okay? So we just wrote the system in a matrix form. So far, so good? If you guys have any questions, let me know. Okay, let's do number 2. This example says 2x plus 3 times x plus y equals 1. All right? And we have 14 equals 6 times x minus y. Now, both of these need to be rewritten a little. We're not going to solve, obviously, because why would you do that when we can do it in a matrix form? But you need to know exactly how many x's you have and exactly how many y's you have. So in this one, I'm going to multiply the 3 in, and in that one, I'm going to multiply the 6 in, but I'm going to do it right here. So for the first equation, I'm going to do an arrow. That. So we have 2x plus 3x plus y, and it equals 1. Now, 3 times x, 3 times y. 2x remains the same. We get, plus. We get another 3x and a 3y. Now, these two obviously can be added. So you have what? 5x and 3y equals 1. This is the first equation. Now let's do the second one. I'll do it right here. Now, this equation says we have 14 equals 6 times x minus y. Okay, so this 6 gets multiplied. 1, 2. So we have 14, which equals 6 times x, which is 6x, and 6 times negative y, which is negative 6y. So far, so good. Now you can write the equal 14 on this side and be done with it, but it's up to you. If you switch sides, the signs are going to switch as well. But anyway, we are good to go. This is my first, this is my first equation, and this is my second equation. Now let's write those in matrix form. Okay, arrow. Here you go. So equation number 1 for the x, and equation number 2 for the x. For the x in equation number 1, we have a 5. So a 5 goes in this column. For equation number 2, we have a 6. So a 6 goes in that column. Now, for the y, equation number 1, for the y, we have a 3. So we put in a 3. For equation number 2, we have a negative 6. So we put in a negative 6. The second equation. Y, and now we write the answers. 1 and 14. And then you close the matrix. So far, so good? All right. Awesome. Did everybody get a chance to copy this, since it's wasn't as short as the first one? Okay. If you ever feel like there's something you didn't catch or didn't get a chance to copy, either let me know or just watch the lecture video again. I will try to pause for a few seconds so that if you're watching the video, you can press pause and just copy what's on screen. All right. Now let's do example number 3. Here you go. Now this one, you're going to have a little more fun. First equation says x plus z and equals, negative 1. That's the first one. Second one, it says y plus 2x equals 5. And the third one says z minus y equals 3. How many variables do you have? We have 3, yeah. Even though each equation technically gave you 2, we have a total of 3 variables, x, y, and z. Like, okay. So, here is my matrix. First equation, second equation, third equation. Right? First variable. Let's start with the x. What's the x value here? Or not value. What's the coefficient of the x here? 1. Right? What's the coefficient of the x here? It's 2 in the second equation. And the coefficient of the x in the third equation is? Care to guess? 0. That's right. Because it is not there. There you go. Now, the next column is going to be the y value, or the y variable. What's the y variable here? It's not there, so 0. Over here we have a 1 and a negative 1. And then another column with the z, a 1, a 0, and a 1. Draw a line, write down the answers. 1, 5, 3. And then close the matrix. Okay. So now we know how to turn a system into a matrix. Can you do the opposite? Because once we're done solving a matrix, you need to turn whatever you have left back into XYZ form. Yeah? So let me show you how to do that. Oops. Oh, let me wait a few seconds for the video. Okay, make it good. Let's do that now. All right, so here's number 4. You have 1, 0, 0. 0, 1, 0. 0, 0, 1. You have a negative 3, 0.05, and a 12. Now, let's say this column is x, this column is y, and that column is z, because that's the usual order. And tell me what the x value is, what the y value is, and what the z value is. See, looking at it like that, when you see a 0 underneath the variable, so this is my first equation, right? Look at the first row. I'm basically telling you that this equation has what? 1x, no y's, no z's, and it equals negative 3. So what is x? It's the answer, negative 3. That's the only thing there. There's nothing else in that equation. What about this one? Y is the only thing there. So what is y? Again, that's the answer. 0.05. And z is 12. All right? So the goal when you're working out a matrix is that after you write it, oh, I'm going to go down a little. After you write it like this, solve it and turn it into this, you find what x, y, and z are. Now, notice how each row has only one variable left in it. That's your ultimate goal. You want, I didn't multiply anything now. You want to get to this point, because once you get to this point, you solved it. You know what x and y and z are. Yeah. Now, oops. Let's do another one. Here you go. Here's 5. Now this one is a matrix that's not been solved. It's just a normal one. It has negative 8, 2, 7 and 0. It's 113 and 1/3. Can you give me the two equations here? And once you're done, tell me what the x value is and what the y value is. First, I want you to give me the two equations. I'll give you a minute to think about it if you like. Again, each row is an equation of its own, and each column is a variable. All right, let's do it together and see if you guys got it right or wrong. Okay, here we go. First row, obviously, is the first equation. Second row is the second equation. Column is a variable. Second column is another variable. This one's x, that one's y. This one's obviously the answers because it's after the line. All right, so we have -8 x, 7y. Since the 7 is positive, obviously it's a plus. And it equals 113. Second one, 2x, no y, and it equals 2. So by this, oh, sorry, not 2, 1/3. Yes. So by looking at this, you can now probably tell the x is what? 1/6, right? Because you're going to divide by 2, or multiply by half if you want, and divide by 2, which is basically 1/6. So it equals 1/6. And you grab that one, plug it in here to find what y is. Yeah? So if you take 1/6 and you multiply it times -8, what do you get? -8/6. Simplify top and bottom, you get 4/3. -4/3, right? So -4/3 plus 7y equals 113. Move that to the opposite side. It becomes positive 113 plus 4/3, which is 1 1/3, so 114 1/3. divide the whole thing by 7, and that's your y value. Now, don't worry about solving it. I just wanted to show you how you translate, that's what we use, translate a matrix back into equation form. All right? Let me see. Now, is everybody good on those? Going from system to matrix and then matrix to system. Because if you have those down, we'll move on. I'm sorry. Can you write that first part down? Ah, you want the calculation? Sure. Just kind of do it in my head. Oops. Okay, so after we found x to be 1/6, we have -8 times 1/6 plus 7 times y, it equals the 113, right? So we're going to move this part here, and it turns positive. So you have 7y equals 113 plus basically 8/6, right? Which is 4/3. But anyway, let me add those real quick, because that's like 114.3 like that. But I want to make sure since I'm doing it in my head. Yep. Now, if you've never seen this little line here before, when someone writes a point number and then put a line on top, that basically means that this is like saying 0.333333. It just keeps going, right? So I'm just saying this is repetitive instead of writing all those threes. But anyway, so this equals obviously 7y. Divide by 7. Oops. Divide by 7. Divide by 7. And y is it's like 49/3, or approximately 16.3. And it keeps going on forever. Okay. Any other questions? Okay. Let me know when you're done, so I could move on. Okay. Now we are going to learn row operations, because obviously putting a system into a matrix form and then from matrix form back to system is not enough for you to solve it. You need to manipulate the numbers on the inside. So there are 3 types of operations that you can use when you're solving a matrix. And those are listed in your notes, but I'm going to write them down anyway. All right, so the first operation, it's called interchanging of rows, right? So it's when you switch 2 rows, or at least 2 rows at a time. You can switch more than 1, but it's 2 at a time, right? For example, I'm going to give you a 2 by 2 because that's the simplest matrix form. Now, why do I call this a 2 by 2? It's because you have 2 variables and 2 equations. Makes sense? You usually don't count the solution. So even though we have 3 columns, technically, these are the variables. So it's a 2. Anyway, so this is the original one, right? See how we have first row, second row, we have 3, 2, 1, -2. Now, if I want to switch the rows, you write it in this form. You say R1, which is row 1, becomes R2, and you draw like a double-sided arrow, because R2 is going to turn into R1. Does that make sense? So this means that you're going to switch them. If I see you write this, then I know you switched them. So now you have 1 and -2, which was the second row in the first row space. And what was the first row is going to turn into the second row. Oops, 3 and 2. See that? So the first column was 3, 1. Now it's 1, 3. Second column was 2, -2. Now it's -2, 2. And the answers are going to switch as well. So here comes a 10. That is -5. Saw that? So we switch the two rows, interchanging of rows. The second operation is the multiplication. Now, when you multiply, you are going to multiply by the row. What is the point of that? To solve the matrix. So these are the operations you're going to use to manipulate the numbers on the inside into giving you zeros. That's how you solve it. Does that make sense? And we're going to get to that part in a minute. But these are the operations you're going to use on the matrix. So first one, switching rows. Second one would be multiplying by a number, a non-zero constant number, right? So it could be a third, it could be a negative, it could be 2, it could be 5, as long as a number. So, oops. Right? Creation by number. Okay. So let me use the same matrix. Makes it easier. 3, 1, 2, -2. Oops. -5 and 10. That's our matrix. Now, just choose one of them. Let's say R1. Yes? I want to multiply by 3. So you're going to write 3 R1. So the first part should be in this matrix. So in this matrix, row 1, this one right here, is going to get multiplied by 3. And I'm going to say that it's going to turn into R1. That means that the row in the second one, or the resulting matrix, is going to be this same one, only it's going to be multiplied by 3. So 3R1 is going to turn into R1. That's the sign you write. What that means is that I'm grabbing the first row, multiplying it by 3. So each value in here is going to get multiplied by 3. Now, I've been asked before, why don't we write R1 turns into 3R1? It's because each R1 you see here is associated to the matrix right next to it. So if I say that the 3R1 is right here, that means I'm technically dividing it by 3, because this one would be 3 times bigger than that one. Does that make sense? So you always multiply the first one, and then you tell me that 3 of the one we already have is going to turn into the first one of the new matrix. Does that make sense? So 3R1 turns into R1. This is the first row. I'm multiplying it by 3. So that means that we have 9, 6, line, and since 5 multiplied by 3 is 15, and it's negative. I ran out of space. That's supposed to be negative 15. Help us clear. Right? Now, the second row, I didn't touch it, so I could just do 1, -2 SDR, and the 10. All right? Now, the third operation you guys need to know about is called the multiplication of a row. And then you add it to another row. So you have multiplication of a number plus addition of a row. Now, what do I mean by this? Here's the matrix we've been playing with so far. right? You have 3, 2, 1, -2, -5, and 10, right? Now, sometimes multiplying by a number wouldn't be enough. You need to add a certain value. So what you would do, for example, if I want to manipulate the second row, I would multiply the first one by a value and then add it to the second one. Does that make sense? And that will give you the second row. So it would look like this. If you want to write it down, the row of operation, it's always helpful to write out what you're doing, but that way, if you make a mistake somewhere along the way, because all you see is numbers, it's very easy to get confused. If you make a mistake along the way, you could just backtrack looking at the operations you did and which one of them didn't or doesn't look right. That way you can catch your mistake faster. So make sure to write out what you do every time. So in this one, for example, I'm going to multiply the first row by 2. So I'm saying I want to do 2r1. Yes? So r1 is being multiplied by 2. And then I want to add it to r2. So I want to add r2 to that. So this one times 2 plus the values over here. And this is going to give me my new r2. Which means that in the new matrix, does this first row change? No, it does not, because this operation is resulting in the second row. This part right here, I'm not telling you to change these, I'm just telling you to calculate what it would be. R2 is the result, and R2 is the only one that's going to change. R1 is going to remain the same. Does that make sense? So this operation right here affects the second row and the one you're about to write. So the first one, you write it as it is. Nothing changes. Okay? Now let's do the second one. Now, the operation said row 1 times 2, and then you add row 2. So, okay. You grab the first value, which is 3, times 2 is 6, right? Plus 1, that makes it 7. Yeah? Now you grab the second value. 2 times 2 is 4, plus, plus -2, and that makes it 2. Now you have a 10, -5. I keep going the wrong one. -5 times 2 is -10, plus +10, the answer is 0. So how that happened? So you start off with the one that's multiplied, grab the value, you multiply by the number, and then you add the other value to it, and that will be the number you add here, or you insert here, I should say, right? 3 times 2 plus 1, 7. 2 times 2, 4, plus -2, 2. -5 times 2, -10, plus 10 is 0. All right. Now, one of you asked me just now, why are we doing this? What's the point? It's because this is how you're going to change the numbers inside the matrix. There's a certain result you want to get to when you're solving a matrix. The matrix has 2 solution forms, the Gaussian elimination method. And when you're solving it, say you have x, y, and z in your matrix. You have 3 variables and 3 equations as a result, right? This is the closest result you want to get to. I should say the simplest, right? This could be anything, so I'm just going to write a square here because I don't care about the value. 1, 0. Could be anything. Could be anything. 1. If you get to this point, right, where the third equation, if you notice here, third equation only has 1 variable, so you technically solved one of them, the second equation has 1 for the second variable, but the third variable, which you already solved, you can just plug in and you solve y. And once you find y, you plug both z and y in the first one and you solve for x. Make sense? So this is the least amount of work you need to do. Now, if you want to be fancy and solve the entire matrix in matrix form without doing the rest of it by hand, this is what you need to get to. It's 1, 0, 0, 0, 1, 0, 0, 0, 1, which is very similar to the example I showed you just now. Because in this one, each equation is already solved. In each equation, you only have one unique variable, and each one is different, so I don't want you to give me x 3 times. So this one's x, that one's y, and that one is z. You already solved it. You just need to tell me what the answers are. Make sense? This is the result you want to get to. And how do you get here or here? Is by doing these three operations. Now, the order, what numbers you multiply, what rows you add, that depends on the matrix you get. Okay? Now let's practice a few row operation examples before we get to actually solving a matrix. Oops, I dropped the page. Are you guys with me so far? Let me make sure you're following. Yeah? No? Maybe? Kinda, okay. Well, hopefully with a little practice, it will be clear. All right, so let's do an example. And if you're still lost after this one, I'll try to explain it again. Okay? So here's example number 6, if you have the notes. Now in this one, here is the matrix I want you to try and, well, let's not say solve. Try and play with. Okay? Let's say you have a -2 and 1 in the first column. You have 4 and 5 in the second column. Here's the answer line. And then you have 10 and 3 as answers, and close out the matrix. Okay, so this is a 2 by 2. Now, arrow, I want you to give me 1/2 R1 is the new R1. So I'm saying multiply R1 by 1/2. That would give you the new row 1 for R1 for this matrix. Okay, so the fact that we're playing with R1 and the result is row 1, that means that row 2 is not going to change, correct? So I will write row 2 as it is. 1 here, 5 here, 3 here. Okay, now let's do row 1. So the first value in row 1 is -2. The operation told me to multiply it by 1/2. It's got blurry. One sec. There you go. The operation told me to multiply it by 1/2. So -2 divided by 2 or multiplied by 1/2 is -1. The answer is -1. And that's my new row 1 value. So the first value turns into -1. Now let's grab the 4. 4 multiplied by 1/2 is going to be 2. So this is my new R1 value. 10 multiplied by 1/2 is going to be 5. And that's my new R1 value. So far so good? So this is the operation you're doing. This one right here is the row you're going to write the answers in. Yeah? Okay. Let's do another one. Here's 7. So that one was multiplying a row by number. Okay. Actually, let's continue. I think there's a continuation to this problem. So I'm going to do it right here. No, there's no room. I'll do it here. So this is not 7. This is just me continuing the problem. I'm copying this part. This is not a new step. It's just the same matrix copied here. So I'd have a longer arrow to write the operation on. Okay? All right. Now, here's a new operation. I want you to do this one, because that's how matrices work. You grab the last result you have, and you work off of that until you get to the solution. Okay, so in this one, what I want you guys to do is add R1 to R2. And I want this operation to be the second row in the new matrix. Okay, so over here, row 2 is going to be R1 plus R2 from this one. So let's look at it. Since the result is the second row, the first row is not going to change in the second matrix. So here, R1 is going to be the same. So I'm going to copy everything you see here. 1, 2, and then 5. Yeah? Now, let's work on R2. It says R1 plus R2. So, oops. For the x value, you have -1 plus 1, and that's 0. That's the result. Now, you have 2 plus 5, and that's 7. That goes here. And 3 plus 5, that's 8, and that goes here. So this is my new matrix. So far so good? Now notice, after we did this last one, what happened? For x, you have a 0 right here. And I have a 7 for the y. So you're almost close to solving it. This basically translates to 7y equals 8. Make sense? So the more steps you do, the simpler your matrix will be, and the solution will be revealed. Now, let's do number 7. Oh, did everybody copy this one before I move on? Just want to make sure everyone has it down. Awesome. All right. Let's move on. Oops. Okay. Now we're doing 7. Okay, this one's a 3 by 3. We have 12, 2, and 2. That's the first column. We have 0, -8, and 1. That's the second column. And we have -6, 4, and 7. That's the third column. Answer line, you get 3, -18, and 0. Okay, so here's my matrix. Operation arrow, new matrix. Oops. Apparently I can't draw a straight line. All right, so here's what I want you guys to do. We want to do a negative R3. So by that I mean I'm going to turn everything you see negative, multiplied by negative, right? Negative R3 plus R2, and this equals my new R2. So in the new matrix, which row am I going to change? Row 2, right? R1 and R3 are going to remain the same. So I'm going to copy those two to avoid confusion. 12, 0, -6, here's the answer line, and 3. That's row 1. Row 3 is 2, 1, and 7. And over here we have a 0. Okay, now let's do R2. Now, here it said multiply R3 by negative, and then add R2. So the first R3 value is 2. Multiply by negative becomes negative 2. Adding 2 to it turns it into what? 0, right? So this turns into 0. Okay. Next value, 1 times a negative becomes negative 1. Negative 1 plus negative 8 is negative 9, right? 7 times a negative becomes negative 7. Negative 7 plus 4 is negative 3. And last but not least, 0, turn it negative, still 0, add it to negative 18. The answer is still negative 18. So far so good? You guys with me on the operation so far? Yeah, okay, cool. If you're not, please let me know. Actually, I'll try to keep it within the screen range for now. Okay, now I'm going to copy this matrix right here. No solutions being done, I'm just moving it here. Okay? So we have 12, 0, 2, 0, negative 9, 1, 6, negative 3, and 7. Number line, 3, negative 18, and 0. Here's my matrix. Done. Okay. Arrow. Now let's play with it. There you go. Now the new operation I want you guys to do is negative 1 over 9. So I'm multiplying it by negative 9th. Or, if you will, dividing by negative 9. Same thing. Okay? So I'm dividing by negative 9. And I'm doing this to R2. And this will give me my new R2. So again, I'm manipulating the second row. All right? The whole thing. Okay. First row is not going to change. 12, 0, negative 6. 3. Let's close it. Third row is not going to change. So 1, 7, and 0. Now let's do the second row. Now in this one, you don't have any other row to work with, just the 2. So let's look at that one. 0 divided by negative 9, still 0. So this one will remain 0. Now negative 9 divided by negative 9, the answer is 1. This turns into a 1. Negative 3 divided by negative 9. You can simplify 3 from the top and the bottom. So it becomes 1 over 3. And the negatives cancel. So this is 1/3. Now negative 18 divided by negative 9 is 2. Since 9 times 2 is 18. And both negative, the answer is going to be positive. All right? Now, did you notice how with these two operations that I did, first operation, second operation, row 2 went from having a 2 in the first value to a 0, and from a negative 8 to a 1? That's what you want to aim for. Your goal is to turn the first value in the first column, first row, to this one right here, into a 1. You turn this one to a 0, and turn this one into a 0. And then you get here. You either turn this into a 0, or it just ends up being whatever number you get if you don't want to keep simplifying. This one right here has to be a 1, which is what we did. And this one needs to be a 0. So we need to continue solving. This needs to be a 0, and that needs to be a 0. We don't care about this triangle right here. These 3 numbers can be whatever you want them to be. These 3 numbers need to be the value 1. And these 3 numbers need to be 0. Okay, now you can turn these into zeros as well, because that will give you the direct answer. If you don't do that, you're going to have to solve the rest by hand. I find that most students prefer to solve the rest by hand because matrices can be tedious, right? So this is the first set of zeros you need to get, and that's the second one if you want to continue. You have to get this line of ones to solve the matrix. So when you are doing row operations, you need to think of this end result in mind. Yeah. So when I made the second negative and added it to row, I wanted to get rid of this 2. Does that make sense? I turned the 2 into 0. That was the point. And over here, after having turned the -8 to a -9, I divided by -9 because I wanted to turn this into a +1, which was the point. Make sense? Because I wanted this one to be a 1. So everything you do needs to be for this very specific purpose. You want to turn this value to a 1, this value to a 1, and that value to 1, these 3 right here to zeros. That's how you solve the matrix. Okay? So the operations are how you do that. Now, let me show you this page right here. This is in your notes. If you don't print them, you might want to write this down. This is called the Gaussian elimination and Gauss-Jordan elimination. Now, what's the difference? For the Gaussian elimination, you end up with the row of ones, as you can see, and the triangle of zeros at the bottom. This is how you solve it. This is called row Euclidean, or at least that's how I pronounce it. I'm sure someone would pronounce it differently. Maybe I'm pronouncing it incorrectly, but it's called row Euclidean. All right. Now there's a reduced row Euclidean, which is the Gaussian-Jordan elimination, and what that says is that you have the row of ones, but you have 2 triangles of zeros instead of just the 1. So everything else in the matrix will be 0 except the 3 variables, and the number of ones is diagonal. That tells you that the first equation, this one right here is the x value, that value right here is the second value, is the y value, and that number right here is the z value. So you solve it. All you have to do is just write x equals, y equals, and z equals. For this one, you did less work in matrix form. You got to this part, and you're like, okay, I know what z is. See that? Because you have line of zeros and the 1, just like here. So z, you already know what it is. Let's just grab that value, plug it in here, and find y, and then grab the z and y and find x, instead of keep working in the matrix. So whichever one you choose to do is fine, as long as you get to the answer. Make sense? So the goal, the main part, is a diagonal line of ones, and at least the triangle of zeros at the bottom. Is everybody with me so far? Any questions, you guys? All right. Yeah, I wasn't talking. Don't worry about it. Okay. So now that we took a look at that, let me do a full example for you. All right. So let's solve a matrix from top to finish, or start to finish. Number 8 seems kind of simple, and I kind of want to show you how to do a 3 by 3. So let's start with 9. Right? 9 in the notes. Let's see what we're going to do. Let's do that. This is 9. Okay? Oops. Okay. Here we are. Now here's the system that we are going to turn into a matrix. We have 2x minus 6y minus z, it equals 7. Okay? Second one is x plus 2y plus z, and it equals 0. The third one is x plus 4y plus 2z, and it equals negative 3. Here's my system. Now let's turn this into a matrix. So for the x column, we have 2, 1, 1, right? For the y column, we have a negative 6, a 4, a 2, and a 4. There you go. 2 and a 4. And for the z column, we have a negative 1, a 1, and a 2. Okay? Oops, the answer line, 0, and the negative 3. Okay, here's my matrix. First equation, second equation, third equation. You guys see how it looks? 1, 4, 2, 1, 4, 2, and the answer is negative 3. Yeah? So we translated the system to a matrix. Now we're going to solve in matrix form. I'm going to copy this one right here. Oops. I want you guys to see it while I copy. 2, 1, 1. Here's 6, 2, and 4. Negative 1, 1, and 2. 7, 0, negative 3. Okay, here's my matrix. Now, in terms of row operations, what do you guys think we should do first? Any ideas? Now, let me tell you this. As long as the end result is 1, 1, 1, 0, 0, 0 over here, it doesn't matter what operation you do, as long as it ends up going to that result, right? And each of you could solve this in a different way. But there's usually a simpler direction to go instead of just doing whatever. And in this case, I'm going to first interchange rows. What I'm going to do is grab the first row and place it below the third. So I'm basically switching all three. I'm making the second one the first, the third one the second, and the first one the third. So I grab this one and place it all the way at the bottom. Okay? So when I do this, this is my end result. We have 1, 2, 1, choose this row, 1, 4, 2, and then 2, negative 6, negative 1, 0, negative 3, 7. You saw what happened there? First row is now the third. Grabbed it, put it all the way at the bottom. Okay? Now I'm going to copy this one right here. You always start with the last matrix you did. So you have 1, 1, 2. We have 2, 4, negative 6, and 1, 2, negative 1, 2 other 9, 0, negative 3, and 7. So that's the matrix. Now, why did I move that line, do you think? It's because of a few reasons. One, if you notice, now the first value is what? It's 1, which I want it to be, right? Second thing is, now the z over here is negative 1. So it would be very easy to turn this into 1, which you do want. Make sense? So by doing this, I turned the first value into 1. So that's done. I just need to turn these two into zeros. I need to turn this one to 1, this one to 0, and that one to 1. So one of the 6 values I want is already in place. And this one's already easier. Make sense? Anywho. Now, let's think about what to do next. Okay, so this one's already a 1. That's good. Now I want these two to be zeros. This to be a 1, that to be a 0, and that to be a 1. Okay. What I'm going to do next is negative row 1. So multiply R1 by negative 1. And then add R2 to it. And this will be my new row 2. Okay, so I'm changing row 2. What I'm going to do is multiply the first one by negative 1. Add it to the second one, and that will be the new second one. Okay, so row 1 is not changing. Only row 2 is. So I'm going to copy row 1 really quick. 2, 1, line, 0. Close it. Okay, now let's do row 2. We have 1, negative 1, plus 1, that's 0. Boom, we got a 0. Okay. Negative 2 plus 4 makes this a 2. Right? And then 1 times a negative is negative 1. Plus 2 makes it a 1. And lastly, you do the answers. Negative 0 is still 0. Plus negative 3, the answer is still negative 3. Yeah, so I got a 0 here. This became a 2, so even smaller. So we're getting there. Yeah. Now, let's do row 3. I'm going to do another operation. Let's say I want to turn this. I want this to be 0, that to be 0, and that to be 1. I don't expect you to do all 3 of the same operation, but let's see what we can do with this one. If I divide row 3 by 2, or to put it in a different way, I'm multiplying by half. Oh, row 3, I'm sorry, row 2. It's row 3. I'm multiplying row 3 by 1/2. Okay? And I'm going to say this is my new row 3. That's it. I just want you to multiply by 1/2. Half it. Okay. So over here we have 2 divided by 2 is 1. Negative 6 divided by 2 is going to be negative 3. And negative 1 divided by 2 is negative 1/2. Right? I'm sorry? Yeah. I just saw a better way to solve this. If you use pencil, erase this part right here, because I think I have a better way. Instead of multiplying by 1/2 now, there's a different operation you can do, which is a addition of rows, and that would actually put us in a better position. So let's do that instead. I want to do this instead to row 3. So forget those 2 values here. Instead of multiplying by 1/2, here's what I want to do. I want to grab row 1. All right, grab row 1. I want to multiply it by negative 2. Yes, so negative 2 times row 1. And then I want to add row 3 to it. And that will be my new row 3. Okay? So I want to multiply row 1 by negative 2 and then add row 3 to it. Okay, so as you can see, if you multiply 1 by -2, it becomes -2. If you add it to the 2 over here, this turns into a 0. So there we got our second 0, right? Now, if I multiply the -2 times the 2 right here, that becomes a -4. Add it to the -6, that puts you at a, -10. Right? So we have 0, -10. And then the 1 times -2, which is -2, plus the -1 puts you at a -3. And for the answer, 0 times -2 is still 0, plus the 7, and the answer is still 7. Okay, so the new row is 0, -10, and -3. Forget this operation for a second. I'm still going to divide it by 2 just a little bit later on instead of doing it now, because this makes it simpler. And I got my 0. See that? We have 0, 0, 0. Okay, so I'm going to copy this one right here. So we have 1, 0, 0. You have 2, 2, -10. 1, 1, -3. 0, -3, and 7. Okay, that's my new matrix. Now, so the new operation I want to do is multiplying row 2 by 5. So this is 5 times row 2. And then add row 3 to it. And that would be my new row 3. Okay, so I'm grabbing row 2, multiplying by 5, and then adding it to row 3. Now, why did I choose row 2? You could probably do something with row 1, and you're right, because the two numbers I need to manipulate, row 2 and 1, as you can see, they both have 2 and 1. The only difference is row 1 has a 1 here, row 2 has a 0. If you use row 2, that means your 0 is going to remain a 0. You're not going to ruin what we just did. Make sense? So since these two are zeros, I'm sticking with row 2. So I'm multiplying it by 5. Why? Because I want to turn this 2 into a 10. So once this 2 becomes a 10, if you add it to the -10, this one becomes a 0. Make sense? That's why we're doing that. So row 2 times 5 plus row 3 is the new row 3. So 1, 0, 0. Those are not going to change. 2, 2, 1, 1. Those are the first two rows. Wrote them down because I'm not touching those. Only row 3. Okay, so 0 times 5 is 0 plus 0 is still 0. So we're good. Now, 5 times 2 is 10. 10 plus -10 is another 0, right? Now, 1 times 5 is 5. Plus -3 is a +2 over here. And 7 times 5 is 35, right? So, no, sorry, I'm multiplying the 3. See, I got confused. -3 times 5, right? That's -15 plus the 7 gives you a -8. Okay. Now the next step, I'm going to do the dividing by half for row 3. Now, can you see why I want to divide by half now? Because the 2, once you divide it by half, it turns into a 1. And then I'd have my 1 over here, my 1 over here, and the 3 zeros. The only thing left would be this 2. Turn it into 1. And you're done. So let's do that. To slide this down a little so I'd have more room. Like that. Now I'm going to copy this one right here. So here's my matrix. We have 1, 0, 0, 2, 2, 0, 1, 1, 2. 0, -3, and -8. Okay? I'm going to take this away now. New operation. Now, the rows I need to work on still are 2 and 3, right? I need this to be 1 and that to be 1. I don't really care about the 3 on top. We can keep going if you want to, but we can stop if you also want to. These 3 are already 0, so that's good. Now, I want row 2 to have a 1 over here. So what I'm going to do is divide row 2 by 2, or multiply it by 1/2, same thing. So half row 2 is the new row 2, and then half row 3 is the new row 3, because it's the same issue. This one needs to be a 1, that one needs to be a 1. So here's the new matrix. 1, 2, 1. 0. Now divide by 2, 1. Divide by 2, 1/2. 0, 0. Divide by 2, 1. Okay? Now the answer first one is 0. 3 divided by 2 is -3 over 2. And -8 over 2 would be -4. Right? So from this point, as you can see, I have my line of 1s right there, and I have the triangle of 0s. We're done. It's like, okay, this is the z column, right? And this is the third equation. This tells me that z is what? It's -4. So I already know what z is. Z is -4. All right. Now from the second equation, I can see that it's y plus 1/2 z, and it equals -3 over 2. So since I know what z is, let's plug in the -4. So y plus 1/2 times the -4, and it equals -3 over 2. Right? So 4 divided by 2 is 2, -2. If you move it to the opposite, it becomes +2. So y equals +2 minus 3 over 2. This is 1/2. So really the answer is 1/2. Y is 1/2. So now we have y. Z, that's y. You use both to find x. So the last equation, or I should say the first equation, is 1x, 2y, 1z. Right? So it's x plus 2y plus c, and it equals 0. So everything is going to even out. Z we said is plus not equal. Right? So 2 times the 1/2 we just found, and z we said is a -4. And this equals 0. So 2 times 1/2 is just 1. And over here we have a -4. Move all of this to the opposite side. And x is +4 minus 1, which is 3. And that's x. So that. So once you got to this point, we already know what z is. You use this value to find what y is, and you use both to find what x is. Make sense? So this is what I mean by doing half of the problem in matrix form and just plugging it in to find the rest of the variables. Now, if you wanted to continue, you would just turn these 3 values also into 0s, and that would give you the end result, and you would have solved the entire thing in matrix form. Now, let's stop here, and I'll continue the rest of the section on Thursday, because I wanted to give you guys a few more examples before we call it quits on this section, because it's really important and it's going to be on the final. I'm going to include one question about this one in the final, so I want you guys to get it down. It's on Tuesday next week, because that's when the semester ends. Yeah, it's almost over. One more class after this one. Okay, So we're gonna continue. This was number 9. So we just did 9, right? Next class we're gonna continue from 10 and 11. There's like 2 more examples left. 10 and 11. We'll get more practice and hopefully you guys will have a better handle on it. Okay? I'll see you guys later. Hello. You guys there? I think we got stuck. Can you guys hear me? I don't think it's working anymore. Let me stop sharing, maybe that'll help. Not good. Come on.